Alright, so in this problem, I have x to the power of x is equal to 100. So I'm going to first start by taking the natural log, or ln, on both sides. So I have ln x to the power of x is equal to ln 100. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front. So this is going to equal b times ln a. So for ln x to the power of x, I can move x to the front, and I'm going to get x times ln x is equal to ln 100. Now ln 100, that's the same thing as ln of 10 squared. So I get x times ln x is equal to ln 10 squared. And if I have something in the form ln a to the power of b, again, I can move 2 to the front, so I get x times ln x is equal to 2 times ln 10. Now, there's something called the W-Lambert function. And if I take the W-Lambert function of something in the form a times e to the power of a, this is going to equal a. So this is basically what the W-Lambert function is. So if there's something in the form a times e to the power of a, that's going to equal a. So what I'm going to do over here is I'm going to rewrite x here as e to the power of ln of x, because the e and ln cancel out, and this results in simply x. So I'm just going to rewrite x as e to the power of ln of x, and I have this times ln x is equal to 2 times ln 10. And now this is in the form a times e to the power of a. So now if I take the W-Lambert function on both sides, this results in ln x equaling w of 2 times ln 10. And now if I take e to the power of both sides, I get e to the power of ln x is equal to e to the power of w of 2 ln 10. And e to the power of ln x, that's going to equal x. So I get x is equal to e to the power of w of 2 times ln 10. And this is equal to 3.597285, which rounds up to 3.597. So this is my answer to this problem. Alright, so in this problem, I have 4 to the power of 1 plus x plus 4 to the power of 1 minus x is equal to 10. So to start, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 4 to the power of 1 plus x. So that's going to equal 4 to the power of 1 times 4 to the power of x, plus I have 4 to the power of 1 times 4 to the power of negative x is equal to 10. Now I'm going to factor out 4 to the power of 1. Actually, before that, 4 to the power of negative x, that's the same thing as 1 over 4 to the power of x, and 4 times 1 over 4 to the power of x is going to be 4 over 4 to the power of x. So now, I'm going to let 4 to the power of x equal to the variable y. So now I have 4y plus 4 over y is equal to 10. And now, to solve this, I'm going to multiply both sides by y. So I get 4y squared plus 4 is equal to 10y, meaning 4y squared minus 10y plus 4 is equal to 0. And this means that 2y squared minus 5y plus 2 is equal to 0. And you have to use the quadratic formula to solve this. So you get negative 5, so positive 5, plus or minus the square root of b squared, so negative 5 squared, which is 25, minus 4 times a, which is 2, times c, which is 2, all over 2a. And this is equal to 5 plus or minus the square root of 25 minus 16, which is 9, over 4, which is equal to 5 plus or minus 3 over 4, which is equal to either 8 over 4 or 2 over 4. Now 8 over 4 is 2, and 2 over 4 is 1/2. So I have y equals 2 and y equals 1/2. Now remember how we let 4 to the power of x equal to y. So I first have 4 to the power of x is equal to 2, and if 4 to the power of x equals 2, then this means that x is equal to 1/2. Now I have 4 to the power of x is equal to 1/2, and this means that x is equal to negative 1/2. Alright, so in this problem, I have 2 to the power of x is equal to 5 to the power of x plus 2. So to solve this, I'm going to first start by using the property of exponents that states that a to the power of m plus n, this is the same thing as a to the power of m times a to the power of n. So in this case, we have 5 to the power of x plus 2, and we can think of a as 5, m as x, and n as 2. So we want to put this in this form right here. So to do that, well, a is 5, so we have 5 to the power of m, which is x, times 5 to the power of n, which is 2. So now we have 2 to the power of x is equal to 5 to the power of x times 5 to the power of 2. And now 5 to the power of 2, we all know that's 25. So now I have 2 to the power of x is equal to 5 to the power of x times 25. Now, we want both of these x's to be together. So to do that, I'm going to have to move 5 to the power of x to my left-hand side. And to do that, I have to divide both sides by 5 to the power of x. So then these two cancel out, and I get 2 to the power of x over 5 to the power of x is equal to 25. Now, if I have something in the form a to the power of m over a to the power of n, or sorry, if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So 2 to the power of x over 5 to the power of x, that's going to equal 2 over 5 to the power of x, which is equal to 25. Now from here, if we want to solve for the value of x, we're going to have to make it a real variable instead of an exponent. And to do that, I'm going to take the log on both sides. So I have log 2 over 5 to the power of x is equal to log 25. And the reason I did this is because I can use the property that states that if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have x times log 2 over 5 is equal to log 25, meaning x is equal to log 25 over log 2 over 5. Alright, so in this video, I'm going to solve the problem 3 to the power of 13 minus 3. So to solve this, I'm going to first start by writing this as 3 to the power of 12 plus 1 minus 3. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So I get 3 to the power of 12 times 3 to the power of 1 minus 3. And from here, I can factor out 3. So I get 3 times 3 to the power of 12 minus 1. Now 3 to the power of 12, I'm going to rewrite as 3 to the power of 6 times 2. And that's equal to 3 times 3 to the power of 6 to the power of 2 minus 1 squared. And I'm writing this like this because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So this turns into 3 times 729 plus 1 times 729 minus 1. This is equal to 730 times 728. So from here, I'm going to rewrite this as 700 plus 30 times 700 plus 28. So this is equal to 3 times 700 squared plus 700 times 28 plus 30 times 700 plus 28 times 30. Now this is equal to 3 times 490,000 plus 40,600 plus 840, which is equal to 3 times 531,440, which is equal to 1,594,320. So this is my answer.